What was it this morning? Discriminant. That was it, yeah. So what we're going to move on to now is long division. Now, not too easy. Can you see that okay, or do we need to close the blinds? It will look a bit brighter once the white notepad opens up. Anyways, we're going to have a look at long division. So, of course, this isn't the long division that you learn in elementary school. This is long division with quadratic and linear equations. Okay?
Everything is with quadratic and linear equations.
Cubic as well, too. Right. Long division. You'll be okay. Be strong. Right. That's okay, isn't it? Yeah? Can you see that okay? Dudes! Hey! Be quiet. Were you speaking Arabic? Let me translate for you. Chub. Tamam? Yeah? Okay. You can be quiet, yeah? Thank you. Thank you. Okay. It's Dubai, isn't it? It's what they say in Dubai. Those.
Yeah.
No.
Everywhere.
Yeah.
Oh, it's okay. I thought it was just a UAE thing.
No. See, Arabic is like England, America.
Yeah. Well, anyway, the important thing is, hang on. The important thing is you understood me.
Tamam, original Egyptian.
Okay. What?
You just forgot it. This is recorded.
Oh my God.
Yeah. Be good now. It's alright. Maybe I'll cut the start out. I don't know.
No, don't cut the start.
I know. Actually, you're right. We'll put a compilation at the end of all the blooper moments or something. Yeah. Right. So long division then. What we have from a basic elementary school example, just to get the idea familiar again in our head. So, for example, if I have 25 divided into 106, how many times is that? That's 4 times, and then you have this piece at the end, which is 6. You remember this? And what's this 6 called? The remainder. Yeah. So we have a similar idea for algebra, except what it'll usually be is a linear term divided into something that's like a cubic. Cubic is x power 3. Okay, so we'll just do some examples to show you how to do this, okay? I mean, some people maybe remember this, some people not, and maybe some people haven't done it before. And in fact, there are different ways to do it as well, okay? So the way I'm going to show you is just the way that it's usually done here, but maybe it's not the way that you saw. So we'll just do our first example, if you can write this down. Okay. X minus 2 divided into 36x cubed minus 59x squared minus 25x minus 2. Okay. Now, actually I should just quick check of vocabulary. You're right. Earlier we said the piece at the end is the remainder. What about the piece on the top here, the answer? Very good, it's the quotient, yeah. That's what you get on the top. Okay. Right, so I'm going to do the long division process. I'll probably do two or three examples, just so you can get the idea. Okay. So the first thing, what you do is you look at the first number here and the first number here, and you say, what do I multiply this by to make it this? Well, it has to be 36x squared. Then what you do as the next step is the multiplication. So then you multiply both of them. So you get 36x squared minus 72, sorry, that's cubed, x squared. So that multiplies both. And then the next step is, does anyone know? Minus. So in a moment we'll have to take away first, so they cancel.
Yeah.
And then this will be minus 59 minus 72, which is plus 72. So what's that, 13, is it? So that would be 13x squared. And then the next step? Yeah, and then the last part of the first sort of cycle is we carry the other pieces down. So then that becomes minus 25x minus 2. So there's kind of 4 steps to it. So we'll do another cycle. So again, step 1, you look at the first one here with the first one here. Yeah, now this is the thing some people do and some people don't. I usually do. It doesn't matter if you don't. It just, I know in some places you just bring one down at a time, but I just bring everything down. It's easier. So we start again. X multiply what makes 13x squared? Well, it has to be 13x. So we multiply and we get 13x squared, and what's next? Minus 26x. That's step 2 done. Step 3 is minus. So they're gone.
I can't.
Is it because it's not bright enough?
No, it's because I'm over here and you're over there, so I think I have to change my face, that's why. Okay?
Yes, but wait until I'm finished. I won't.
see anything at the top.
No, can you?
No, I'm being rude over here. I just want to show you.
Well, that is true, but do you need me to move more or like what?
It was.
Hurry up, hurry up.
Thank you.
You have until I take a sip of coffee. Okay, continuing now. So here we have minus 25x minus 26x. So what have we got here? X. And then the 2 comes down. So that's minus 2 and carried down. So we have one more cycle to do. Last one, x to make x. Just one. And we have x minus 2. And then we're left with 0. No remainder. Okay. So that's our first example. If you can write that down, please, and then we'll look at what we can do with long division and some more examples. Okay. Don't worry, I'm not waiting for you. I'm just relaxing for a second. Okay, some more terms and ideas now. Actually, I wonder now, especially in South America, but other places too, you do the long division some other way, where you write like this, and there's a...
Yeah.
That's you, is it? Okay, and you as well, okay, yeah.
I do it like that.
That way as well. Okay, there's always a couple of people. And it's not quite the same as how I'm doing, isn't it?
You changed it.
No, I didn't change it. This is how we do it here. Yeah, but if you want to use it the way you're familiar with, that's fine. But I'm just going to keep doing it this way in class. So maybe you want to practice a few of them this way. And more importantly, in past exams, it will be done this way. So if you were reading past exams, the solution would look like this. So it might just be best to learn how to do it this way as well. Okay. Right. Continuing then. So some applications, some vocabulary. Okay. So if I have 100 is 25 multiplied by 4, we can say that 25 is a what of 100? It's a what? Thank you, yes, thank you. That's what I was looking for. It's a factor. Yeah. It's also a fourth too. Yeah. So the way you can check if something is a factor is if you divide it in, the remainder should be 0. A multiple would be like 25, 50, 75, 100, 125. Yeah. So they're kind of like a list almost. So if it's a factor, the remainder should be 0. Yeah. So this is how we can check for a factor. The remainder should be 0.
Or a factor as well.
And 4 will be a factor as well. Yeah. So we can use the same idea for long division for algebra as well, that if the remainder is 0, the thing you're dividing in is a factor. Okay, so let me do a simple example. So for example, I want to check if x minus 1 is a factor of x squared minus 3x plus 2. Yeah? It's okay? Just divide it the same way. Yes. Now we have lost students. Are they going to come in or not? They haven't decided yet. Right. So we just divide it. And if we get 0, then it's a factor. And if it's not 0, then it's not a factor. So we have x minus 1. Passing through.
Sorry.
Stop. So to get to that way, you have to go down, under, and up.
Okay.
Yes? Okay. Right, so dividing x minus 1 in, x squared minus 3x plus 2. So what have I got first? X, yeah. So here we get x squared minus x. And then when I subtract, what am I left with? Minus 2x and carry plus 2. The last one? Minus 2. So we get minus 2x plus 2, and the remainder is 0. So therefore, this is a factor of this. It can divide in, yeah?
If you're just checking, like you don't need the answer, if I think that the remainder should always be 0, or you should always think the factor must always be divided, doesn't that mean that if you put x equals to 1 into x, your answer will be...
That's right, and that's actually going to be a later lesson. We haven't done that idea yet, but what you're talking about is a lesson later called the remainder theorem. And it's another way to check for if it's a factor. So you're right. Just for today, we're going to do it this way. Okay, so what does it mean to say it's a factor? That means you can say x squared minus 3x plus 2 equals x minus 1 multiplied by something else. Just like in my example earlier, when I said 25 is a factor of 100, that means I can say 100 equals 25 multiplied by something else. Okay? So factor just means you use it to multiply to make it. Yeah.
Or divide to find it.
Yeah, or divide, yeah. To find what it is. Okay, let me give you one example just to practice your long division. Can I scroll down? Yeah. So I want you to check using... Oh yeah, and I should say in the exam, sometimes they specify the method. So your method is called remainder theorem, and this method is called long division. So the question might say, check using long division or remainder theorem if we'll go with x minus 3 is a factor of x cubed minus 2x squared plus 6x minus 26. Okay, I want everybody to do the long division and see if it's a remainder or not. So try that now. In this case, you think it's not. Yeah, you had a remainder, did you? Yeah, and what was the remainder? Okay, so let's do this quickly since it seems like most people have it. So what did you get first? Was it x squared? Yeah, so you have x cubed minus 3x squared. Take away, and I have x squared? Yeah, plus 6x minus 26. So here must be plus x squared minus 3x. What's that, 9x? 9x minus 26 plus 9. So we have 9x minus 27. Yeah, so the remainder here is 1, so it's not a factor. Yeah. And in the last, I'll go back to this in a minute if you didn't get it. In the last one we had, it was a factor. So we've looked at one of each. But just to say, maybe if I look back at the last one for a moment, let's get this thing out of the way. In the last one we got remainder is 0, in the one before. When we divided by x minus 2, the quotient was x minus 1, the quotient was x minus 2. So I just want to remind you, back to our example with 100, if I divide 25 into 100, I get 4. So you can say that 100 equals 25 multiplied by 4. Okay, so you can say that this equals this multiply this. Yeah, and you can do the same thing here. You can say x squared minus 3x plus 2 equals x minus 1 multiplied by x minus 2. So the same idea works here as well. And you'll need that for the next example I'm about to do. So let me just, sorry, does people need to write this down? Yeah? Okay. Say again? I think I would just say or equals 1.
No, like this, like as the improper fraction, the same way you write it here as well.
Yeah, no, we'll worry about if there was a remainder. That's semester 2. Yeah, we'll worry about that later. Yeah. Right now we'll just keep it so that the remainder is 0 for most of these. Yeah. Okay. What I want you to try and do before I do it here, let me just make some space. Let's say I want you to simplify this. 9x cubed plus minus 12x squared plus 7x minus 4 all over x minus 1. I want you to try to simplify this. See what you can come up with. What does your heart tell you? Yes.
I like how you said that.
No. You have an idea what to do? You, yes. No? You think you have an idea? Here. Look at this, look. Look up. Look up. Look. What's this? How did you get that? You did this, didn't you? And you got 25. Yeah? So, here, what do? You divide it, yes. Yeah, so. Now, voila indeed. So, what's wrong with this? Why is this wrong? There's a remainder, yeah. So it works if there's no remainder. So if you do the long division and don't get a remainder, then you're fine. That's your answer. Okay. So let's just do the long division here. X minus 1. Listen. Divided into 9x cubed minus 12x squared plus 7x minus 4. Yeah. Okay. Let's have a look here. So this will be 9x squared. 9x cubed minus 9x squared, and then I'm left with minus 3x squared plus 7x minus 4. Next, minus 3x, so that's minus 3x squared plus 3x, so I'm left with 4x minus 4, so that has to be a 4. The remainder is 0, so that means back up here you can say, well, this equals, well, it'll equal that. So if I just put it over here, so this equals 9x squared minus 3x plus 4 is the answer.
Correct.
Yes? Oh, I know it is. Right, okay. On to another example now. Yep. Okay, so last week we saw how to factorize quadratics. Yeah? So what we're going to have a look at now is how to factorize a cubic. So for example, we'll say factorize 5x cubed. Yes?
In case there was a remainder, how would we write that?
Yeah, that's something we'll look at in semester 2, but I'll give you an example with some numbers. So like if you had 25 into 106, that goes 4 times with remainder 6. So you could say 106 equals 25 times 4 plus the remainder. So basically the remainder has to be added on then after the multiplication then.
I took an elementary school that we put a decimal point onto something when the remainder.
That's to get it.
No. For this, we'll kind of have an example like that later. You'll see. Yeah. Okay. Factorize this, and I give you a little hint. The hint is x minus 1 is a factor. So basically, to factorize a cubic, they don't need to, but it's helpful to be told one of the answers already, one of the factors. So how many factors should there be altogether? There should be 3. So we have this should equal 3 factors, 1, 2, and 3. Now the good news is we already have one of them. Yeah, well the factor would be x minus 1. So like I said, they don't need to give you one of these factors, and we'll look at what to do later if they don't. For today's lesson, one of the factors is always given to you in the question. Okay. Right, so let's have a look here. This is the question, this is the answer now. So basically we want to try and find the other 2 factors here. So the trick is, you divide both sides here by x minus 1. You see that? So these cancel, and that means the factors I get will be the answer here when I long divide. So now we just have to long divide. So we have x minus 1 divided into 5x cubed minus 11x squared plus 15x minus 9. The answer up here will equal the 2 factors. So this will be 5x squared.
Yes.
5x cubed minus 5x squared. I'm left with minus 6x squared plus 15x minus 9. So next is minus 6x. Minus 6x squared plus 6x. So that's 9x minus 9. So finally is 9. 9x minus 9. Should I get 0? I must get 0. Why? Yeah, because I told you already it's a factor, so you should get 0. So it's not quite finished, because I said the answer will be the two factors, but this is the answer here.
So we have to factorize.
We have to factorize this to get the 2 here. This quadratic to get the 2 answers here. And that's something, Negative what? For this? That's fine if it's negative, then it means it has no factors, yeah. So here, let's have a quick check if it does have factors. Discriminant is 36 minus a very big number, like 420 times 9, 180, isn't it? In fact, this has no factors, so that's not a big deal. It just means we only have one factor here instead of breaking it into the 2. So our answer will be x minus 1 multiplied by 5x squared minus 6x plus 9. We can't factorize that quadratic. And this also happens in the exam as well. So I'll give you one to try, and then I'll do it. Yes? Yep. So we can't factorize this quadratic into 2. If what? If, yes? Yeah. This is the answer. Oh, you should factorize it. You should try to factorize it. But not this one. Yeah. I would just use the discriminant to quickly check if it has factors. Yeah. Yeah, because you'll be spending a long time trying to find factors here since they don't have any.
It's like discriminant, like you find the roots are the factors in it.
Yeah, the roots, we'll talk more about that. You can use the discriminant to find the roots, but that's something in a different lesson I want to do. Right now we're just using the discriminant to quickly check if it has 2 answers. Because if it has 2 answers, then it has 2 factors then.
Because it's negative, it has no answers.
In this case, yeah. So we can't do anything with it. I'll give you one to try, and I'll pick one that does have factors, okay? Can I scroll down?
Can we just forget it?
Well, I'll write it down here. I want you to factorize. Let me make sure I pick one that has factors. Yeah, okay. Oh, come on. Right, factorize this for me. 18x cubed minus 29x squared minus 67x minus 24, and the hint, one of the factors is x minus 3. Question, yep?
So I think when's the answer?
For the last question,
Yeah.
this is the answer. That's the answer, presented like that.
This is only 2.
Only 2. Well, there should be 3, but that's because we can't factorize this one. So you can leave it as 2, and this happens in the exam. Yeah, I know it's not 3 factors, but it's kind of like there's 3, because this is a linear, which is 1, and this is a quadratic, which is 2. It's kind of like having 3 linears, linear, linear, linear. Well, you must leave it like this in the exam. Yeah. So in the exam, this would be the answer, exactly like that. Yeah. Okay, try this one. Finished? Finished? Why, you don't sound sure. Finished? Yes or no? Oh yeah, because you missed that lesson. Yeah. So that's okay. You can just leave it there, and I'll do it in a second. So you managed to get it down to a linear and a quadratic then.
I tried factorizing it, but I don't know.
That's okay. We'll have a look at that now.
So we would be using the minus equals to...
In time. Be patient, okay? When semester 2 comes around, you'll be begging me to go slower, okay? So just enjoy the pace at the moment, alright? Okay. Finished? How far did you get? Did you do the long division? Okay. You got the long division done? Okay, let's have a look at this now. If you can look up, we'll do it. So we have 18x cubed minus 29x squared minus 67x minus 24 equals x minus 3 factor and factor. So again, we divide by x minus 3 as normal. So that means we have x minus 3 divided into 18x cubed minus 29x squared minus 67x minus 24. So first will be 18x squared. So that would be 18x cubed. And then 18 times 3 is 54, is it? Minus 54 x squared, that's 25. 25x squared minus 67x minus 24. So next must be 25x. 25x squared minus 75x, leaving me with 8x? 8x minus 24. So it has to be 8 at the end, giving me 8x minus 24, which is 0. So the factors here will be the two answers I'm missing. Right, so let's see, we want 18, so we suppose we could try, and 25 is pretty big. 6 and 3? 6 and 3 first, and then maybe 2 and 4. Yeah, because... you think it's 9 and 2? 9x, 2x, and then the 8, 4 and 2? 2. 8 and 1? Oh, this could make 16 in the middle and 9 on the outside, which is 25. Great. So there are the two factors there. So we have the answer is x minus 3 multiplied by 9x plus 8 multiplied by 2x plus 1. Okay. Yes? Which one? Factorize. Let's not say guess.
We work it out.
Yeah. You stick with it for a while. Yeah.
About this factorizing one of the number, you could use when you multiply it in the 8. You could put two numbers down when you multiply it in the 8, which is 1 over 4.
Yep.
You get, and when you add two numbers, you get 25.
That's it. Yeah. So you're looking for two numbers. At the front they must multiply to make 18. At the back they must multiply to make 8. And then the inner part plus the outer part has to add to 25 then. Yeah. Yeah. Continue? Okay.
We took this. Like the factorization.
Yeah, last week. I remember.
This sounds like a month back. It was a month ago.
Yeah, this is week 2. Yeah. Day 2, week 2, okay? Right. So there's an example I want to do for you, and I kind of want to do it to show you that it's more flexible than just linear, quadratic, and x. You could have something like x and y. So for example, x cubed minus y cubed over x minus y. I want to simplify this. So I'll do this one. Just watch carefully. Is it? Why? What are you left with? The name of the lesson, long division? Yes.
And you multiply by 2 x squared.
Yeah. Alright. Okay, let's go for it then. So what do I have first? Go on, tell me.
X cubed minus y.
Yeah, and what goes here?
Yeah, x squared.
X squared. So we multiply by x squared and we have x cubed minus x squared y. Yeah? What's wrong? This is right. Yeah. Now what I would really love to know is the next step. So just wait. I subtract and I'm left with minus y cubed plus x squared y. Alright, so now what's the next step? This is what I'd love to know.
Wait.
Did you just call him a gabi? That's what I heard. What did you say?
Gabi.
Oh, sorry, I thought you said gabi. No. Be good, okay? Yeah, I don't know what this one means.
Gabi means Indian.
No, I know that. That's what I thought you said. Yeah? Yeah, I know this. Yeah. I know some Arabic. Now, he's giving me suggestions. You're just giving me trouble. Exactly. Now, do you have an idea on what to do next?
Okay, y squared.
Let's see. Yes, we can try that. So we'll try y squared. We'll see what happens. So if I put in y squared, what will I get?
The minus y squared.
You want to go for minus, okay? We'll see what happens, okay? So, I think you might have been better with the plus though, because when you multiply this by this one, it will make minus y cubed, and when you multiply y squared by x, you'll get, what do you get? xy squared. Now that's actually good. That's right, they'll cancel here. So when you minus, they cancel, and you're left with x squared y minus xy squared. Now they don't cancel. So, what's next? Yeah, come on, you're just one step away from finishing. Not you are not helping right now.
You will multiply x minus xy minus xy.
You're going with minus xy.
Yeah.
So the first one will be
Xy squared.
x squared y, and the second will be x squared y. That one will be a plus, and this one will be a minus, wouldn't it? Minus xy by that is a minus, yeah? Oh, sorry, I said it, but I wrote it. This is xy squared with a plus.
No,
and
minus.
no, minus by minus is plus. But you want it to be minus, don't you? Hang on. Yeah, I think you should make this a plus.
Yes, I will.
Right, so that's a plus and that's a minus. Now when I subtract, what do I have? Yes. So you are correct. Yes. Congratulations. What? He did it. What are you talking about? He doesn't believe in
He
you.
just wants to push me down.
He does, yeah. He is a hater.
Yeah, nothing can stop me.
And haters gonna hate. Okay, I'll leave you with one example to try. So I want you to, I'll go back, yeah. When you write it down, I want you to try this one, okay? I'll put it here. So when you finish writing that down, I want you to try this one. Okay. When you finish writing that down, try the one on the left. So I want to see what people come up with the one on the left. Are you trying that? Maybe? Yeah, so far so good. Continue. You did 1 first, and then 1 minus x times 1 is 1 minus x, and 1 minus them. So I think that should be plus just. Yeah, so that's a plus, yeah. So then what's the next one? You want to make this equal to x. So, the next one, yeah? Yeah. Not quite. You can continue. Okay, let's have a look at that one there. And actually, this one here is an important result for a later chapter. So if I just go to the left here. So we have 1 minus x divided into 1. So what's the first number? I think I saw a few people got the first number. What is it? It has to be 1. So we have 1 minus x. Take away, and I'm left with x. Yeah? X. Yeah. Now, what's the next number? And remember, we're trying to match this to this. So the next one should be x. And you have x minus x squared. What am I left with? X squared. Now, what's the next one?
X squared.
Plus x squared. And what do I get here? X squared minus x cubed leaves me with x cubed. So it's repeating, yeah. So it's just going to keep continuing like that. So you end up with this result. 1 over 1 minus x equals 1 plus x squared plus x cubed, and it just continues like this.
Do we write that next time?
Doesn't end. Yes. Yes.
How do we answer an exam?
No, like this. Just like this. No, it does, but it doesn't terminate. It continues. Okay. Now, if you think about it, you have seen something like this in elementary school when you did problems like this.
Yeah.
So you get 0 point and it continues, which is like saying the answer is 3 over 10 plus 3 over 100 plus 3 over... Can you see the comparison? That this is the same as this, and it's a similar idea to what we're doing in this example. That you have a long division that continues, but you have the feeling that each one gets smaller, maybe. Yeah. Now, I know at the moment it looks like it's getting bigger because the powers are increasing, and we need to talk about this more in a later chapter. But this result is a useful result, and if I change the letter, maybe some people recognize this formula from sequence and series, if I have it like this. You've seen this before, yeah. So by simply changing the x into the or, now it's something familiar. Yeah? Yes? Yeah. Okay, so I'll give you some questions then. I will say AB. From each one, AB. Yeah. And this is, again, something that I think will be on every exam, long division. It'll be somewhere on the exam. It's a bit like quadratic equations and linear equations. It's so basic that it kind of has to be on the exam. Okay. So A and B in each of these. Okay.